Alright, so this is the 9192 review. Number 1 says secant to the 4th x minus tangent to the 4th x equals 2 tangent squared x plus 1. So we have to prove this identity. So you guys tell me, what should my first step be?
Pick a side.
Well, pick a side. Okay, so which side?
Left side.
So we want to work with this left side, okay? What should we do to that left-handed side?
Change the secant
Do
to
the
be like
secant.
hands.
Do like secant or root. I forgot, what is it called? When you like make it into two different squares.
So you want to factor it.
Yeah.
Okay. So so you guys said that this is a difference perfect squares.
Yeah.
So we're going to factor it. So we have secant squared x plus tangent squared x times secant squared x minus tangent squared x. So a hint on one like this. If you ever see something that's taken to the 4th, you have two things that are taken to the 4th and they're subtracted, factor them. We don't have any identities for stuff taken to the 4th, right?
Right.
So try to get it to squares. That goes back to the Pythagorean identities. So think about what you're given and what you know. Those will kind of clue in what you should start using. Yeah, Shemaya.
It was pertaining to this.
Okay, go ahead.
I was gonna ask you, doesn't the subtraction one equal 1?
So this subtraction side. So Shemaya's asking if that equals 1. Does anybody else think that this equals 1?
I think that as well.
Okay?
Yes.
What identity are you looking at?
The 1 plus tangent squared x equals secant squared x.
That does equal 1, yeah.
So if we want to get so that we have secant minus tangent squared, we'll rearrange. So we'll have 1 equals secant squared x minus tangent squared x. So that portion does equal 1. So then we're left with this side. So we have secant squared x plus tangent squared x, and then that would be times 1, which would just be that. So we're trying to get to 2 tangent squared x plus 1. So we have 1 tangent squared x right here. So we must have to do something to this secant squared x. What can we do to that secant squared x?
Oh, secant equals tangent square.
So we could go back to this identity that we already used and redefine what secant means. So we can write that the secant now is 1 plus tangent squared x and then plus tangent squared x. So then what can we do?
Combine those two tangents.
We can combine like terms. So we have 2 tangents now, 2 tangent squared x's, and then plus 1, which is what we were trying to prove. All right. Is everybody got this? Okay. All right, number 2. Says cosecant times cosecant plus cotangent x, and says that that equals 1 over 1 minus cosine x. So for this one, Which side would we like to work with?
Left.
Left-hand side again.
Should,
What should we start out doing on that left-hand side?
should we avoid distributing or should we distribute?
Do you want to distribute or do you not want to distribute?
I feel like with the fact that that would cause like a squared x, that'd not be the best idea.
No, this is
So you want to distribute?
Which was easier?
No. Okay. Alright, so if we don't distribute, what else can we do?
divide.
So we can put it in terms of sine and cosine, because again, you want to look for hints of what you should be doing. So for this one, nothing is squared, so that eliminates our Pythagorean identities right now, right? Because we don't have anything that's squared. And all of our Pythagorean identities dealt with things that were squared. So now, the only other thing that we know how to do is to rewrite things in terms of sine and cosine. So we're going to rewrite these in terms of sine and cosine. What's cosecant? Is 1 over sine x. And then we're multiplying by, again, 1 over sine x.
And then 1 over tangent.
And then plus 1 over tangent. But if we're writing things in terms of sine and cosine, we might as well put the cotangent in terms of sine and cosine too right now.
Which is over sine over cosine.
So what's cotangent?
Cosine x
One.
over sin x.
So it's cosine over sine. Remember that it's the reverse of tangent.
Someone's phone's ringing.
Okay.
Click it twice.
So now looking at this written in terms of sine and cosine. Oops. Sorry. That should be a sine.
I do that too. No idea.
So now that we have that in terms of sine and cosine, what should we do? What?
You combine the 1 plus, over sine x plus cosine over.
So we can combine these because they have common denominators.
And then that's dividing,
So we're going to have 1 over sine x multiplied by, this becomes 1 plus cosine x all over sine x. Okay? So now, Brittany, what should we do? What did you say? So now we should distribute. So when we distribute, we're just multiplying across. So you're going to have 1 plus cosine x all over, we have sine x times sine x, which is sine squared x. So now, we didn't have squares before, but now we have one. So can we relate this back to one of our identities?
1 minus cosine squared x.
Yep. 1 minus cosine x.
So the original one is the very first Pythagorean identity that we learned. It's sine squared, or cosine squared x plus sine squared x equals 1. But then we can solve for that sine squared x. And we get that sine squared x equals 1 minus cosine squared x. So we can use that to reorganize, or to rename our sine squared x.
Yep.
So we now have 1 plus cosine x all over 1 minus cosine squared x. So we're getting closer to where we want to be. So what can we do?
Factor out the bottom, so it's 1.
So some of you are saying that we
Yeah.
can cancel, that we can just cancel out a cosine.
No, you
Calc
have to
the
factor the
factors.
bottom.
Because you're adding and subtracting here, you cannot just factor out that cosine. So over here, I heard what you guys were saying. What did you say?
Factor it out, so it's
We need to factor that bottom. What is that bottom?
1 minus cosine x times 1 plus cosine x. Difference.
So it's a difference of perfect squares again?
Yeah.
So alright, so I'm running out of room, so I'm just going to kind of continue right here. So we're going to leave the top, that we have 1 plus cosine x. And that's all over. When we factor that, you get 1 minus cosine x times 1 plus cosine x.
And then those cancel.
So the 1 plus cosine x's cancel out, and you're left with 1 over 1 minus cosine x. which was what we were trying to get.
I was okay.
All right, so moving on to number 3. Number 3 says cotangent x over cosecant x minus sine x, and that equals secant x. So this one is fairly obvious which side we're going to start on. We're going to start on the left-hand side. And looking at each of our terms, what do we notice?
We should put those into sine.
We should put them in terms of sine and cosine because, again, we don't have anything that's squared. So, huh?
I said or anything in these rotation.
Yeah. So, what's cotangent?
Isn't it?
So it's cosine over sine. So we have cosine x over sine x. And then that's all over. What's our cosecant rewritten? Is 1 over sine. And then minus sine x still. So now what should we do?
You can make the bottom so you get 1 over sine x minus sine squared x over sine x.
So you want to get common denominators. So we'll pretend that this is over an imaginary 1. Multiply by sine x so that we can get common denominators. So you end up with the top stays the same. And the bottom, I'm just going to combine them. You'll end up with 1 minus sine squared x all over sine x. So now what do we notice? So we can flip and multiply. So if we were to flip and multiply right now, we'd have that cosine x over sine x. And then we would be multiplying by the bottom flip, so we would have sine x all over 1 minus sine squared x. Okay?
Can't you, isn't one
You can change
minus, yeah, cosine squared x?
So this 1 minus sine squared x we can rewrite as cosine squared x.
this from the.
So again, I'm going to continue over here.
then she flipped the bottom bracket and multiplied it by
Denver in the question.
Yeah, Denver. Where did I lose you?
The second thing,
Here?
the multiplying, no, with the multiplying by
Here?
the sign, no, yeah, I don't, what?
Okay. So so we took our original and we rewrote everything in terms of sine and cosine, right? Are you good with that?
Yeah,
That cotangent is cosine over sine,
yeah,
cosecant is 1 over sine, and then we still have this minus sine, right?
yeah.
Okay, so what we did here is we multiplied the second term on the bottom by sine x over sine x so that we could get common denominators so we could combine the bottom. Because this is already over sine x, and this is over like an imaginary 1.
Oh, never mind, okay.
So we're just getting common denominators so we can combine it down
The
here.
common denominator part, excuse me, I have it.
So you're good now?
I thought
Okay.
that, yeah, I got it.
Okay. So Jasmine just said that we can rewrite 1 minus sine squared x as cosine squared x. So we're going to have cosine x over sine x times sine x over cosine squared x. So that's just rewriting that bottom term. That's using our first Pythagorean identity again. So now that we're multiplying those two fractions, what can we do? We can cancel out the signs. What else can we do?
Factor the cosine squared x into 2 cosine.
We can cancel out a cosine. So we have a cosine here and we have a cosine squared here. So we're left with 1 over cosine x. And 1 over cosine x is secant x, which is what we were trying to prove.
Makes me so happy when stuff works.
Oh my god.
What happened to the one minus?
This?
Yeah.
Okay, so that 1 minus sine squared x became this cosine squared x. That goes back to cosine squared x plus sine squared x equals 1.
Okay.
And then we can solve for cosine squared x.
Okay.
No.
Yeah.
So that was what that step was.
Okay.
Okay?
We just didn't feel like writing it down.
Huh?
We didn't feel like writing it down. What's wrong with you?
May I use the rest of the sign?
How was she supposed to carry some tests?
Exactly. She's like,
Alright, so moving on to number 4. So we have sine x times sine y equals 1/2
this one hurts my brain.
times cosine of x plus y, or x minus y, sorry, minus y, minus cosine x plus y. So you guys should recognize that this is moving into 9.2, into our addition and subtraction identities. And we're going to start with the right-hand side, and we're going to show that that equals the left-hand side. So we want to expand each of these using the identities. So we have 1/2 times, our first one expands to what?
Cosine x times cosine y plus sine x times sine y.
Alright, whoa. That was way too fast.
So that is the cosine, that's cosine subtraction identity. That's how you expand that.
Wait,
So this
oh,
becomes that whole thing, in parentheses
I
there.
don't like that, doesn't make any sense. I get it, but I don't like it. I don't like that.
Well, we don't like that.
So you're just expanding it using the identity.
I don't like it.
Because remember for cosine that it was, that when you were doing the subtraction, when you expanded it, it was an addition.
Oh.
That was what we talked about like the first day in 9.2, when we just first introduced the identities. So then we're subtracting cosine x plus y. So we have to expand the cosine x plus y. So that's our cosine addition identity then.
Yeah, same thing, just with sine.
So it's the same thing, just with
Minus.
a minus. Alright. So now that we have this expanded using our identities for addition and subtraction, what should we do?
Something that makes that look not like it is.
Like, can we cancel off the
You gotta
What's the word I'm looking for?
Distribute the
Distribute, there we go.
So alright, so let's distribute the negative. So we have 1/2, and I'm going to remove the parentheses now just because we're not going to need them. And then distributing that negative, we have minus cosine x, cosine y. When we distribute the negative here, that becomes positive.
Okay,
Big bang.
and then
Cancel.
So now what cancels?
the cosine xy.
So we have a cosine xy, cosine x, cosine y here, and then a negative one there.
And then we just have to.
Then you got.
And then we can combine those, so we have 1/2 times 2 sine x, sine y's. So now what?
Distribute the half and become cent.
So you can distribute the half or just recognize that the 1/2 will cancel out with the 2,
Yes.
and you end up with sine x, sine y, which was what we were trying
That
to
one is easy, I like it.
do. You like that one?
Can we just have all those?
We should have 6 of those on.
That, I'll be happy.
Same exact problem.
I colored it. Colored. I read the book. I feel like Abby's gonna color them.
I feel like these are more for burns.
What? What is it?
Alright, so number 5.
That's cool. Yeah.
Yes, please, hit me on the
Go see all
So this one, we're just changing it. Or what do we-
Okay, so this one says to simplify. So what are you asking, Shemaya? Are we just changing it to what?
Are we bringing, we're changing it into like the sine x plus y?
So we want to figure out which identity this corresponds with.
Oh,
Sine cos.
yeah, the sine.
Yeah, sure.
So this corresponds with our sine addition.
Yeah.
So we're gonna have something plus something inside here. So what do I fill in there inside?
Sine.
So those are our 2 angles that we're given. We're given a 7 and we're given a 3. So then we can just simplify that as sine of 10.
Oh,
I like these the best.
And that'll be your answer because we don't know how to find the sine of 10 without a calculator.
What?
Wait, is
My mind is blowing.
what happened to the cosine?
Okay, so what happened to the cosine? So I was asked this in second hour too. So what we're doing with this part is we're figuring out which of the identities this goes along with. So it's going to go along with the sine addition identity, sine subtraction identity, cosine addition, cosine subtraction. It's going to go along with one of those. This is like the expanded version, so like the long version of the identity, and we want to get it back to this shorter version. So we have to figure out which one this goes along with. So sine, your pattern is that you have a sine and a cosine, and then you have a sine and a cosine. So since we have both terms or both functions in each term, we know that it's going to be a sine.
That makes sense.
And then because we're adding them, we know that it's the sine addition. So we're not getting rid of the cosine, we're just figuring out which identity it goes with. And this one happens to correspond with the sine addition.
Doesn't it have the same numbers?
You mean for like 7 and a 3 and a 7 and a 3?
Yeah.
Yeah, because when you expand those are the only 2 angles that you
Oh,
have,
yeah, yeah.
or that you're using when you expand the identity. Otherwise it doesn't fit with the identity. Alright, so number 6 then. Number 6 says cosine of x minus y
Yo, this is not.
times cosine of y minus sine of x minus y.
Can I not 12? I'll have to be cool, like you guys. Can I
Oops,
use mine?
sorry. Sorry.
It's a sine y. I don't understand it, but that's sine y.
Sine y. Okay, so again, we need to simplify that.
So we're simplifying with those.
So we're simplifying that with the addition and subtraction identities. So which identity
Cosine
does
addition.
this look like?
Cosine
The
addition.
cosine x, cosine y plus sine x sine y.
Yeah,
The
cosine.
addition cosine.
So which cosine one? The addition or subtraction?
Subtraction.
Yeah.
Addition.
The addition one.
The
Add in
addition.
the subtraction.
Okay, wait. So,
No,
which addition or subtraction identity does this fit with?
The addition.
the addition.
Which
Wait, no, no,
addition?
A cosine addition.
This
Yeah.
fits with the cosine addition. This
So
looks
that's-
like the
So
cosine
that's how
addition.
we call it instead of just saying.
Huh?
So it becomes x, y, minus.
So, okay, so we know that it goes with the cosine addition. So we're gonna have cosine of something plus something else.
Yeah.
So what are our angles that we're using in this case?
X minus y and
We're
y.
talking about the whole thing.
Yeah.
I thought we were just, okay. Got it.
And then we have a y. So, so you were confused about this?
Yeah, I thought we were just like gonna split that whole thing up.
So we can extend it further, but we want to simplify it. So we want to make it smaller rather
Yeah,
than
that's
bigger.
what I thought.
No, there's not even places.
So if we have cosine of x minus y plus y, what can we simplify that to?
Cosine X,
Cosine x.
yeah.
So our y's are going to cancel out because we have a negative y and a positive y. So we're just going to end up with cosine of x.
And that could become 1 over
Well,
c.
I started.
Yeah, I thought we were like staying and stuff.
Alright. So now we're on to the back.
And this is when we expanded. Okay.
Stuff makes sense to
I like it. That's why I crossed way.
Alright, is there a question? Alright, number 7. We have tangent of pi plus x.
And I'm waiting for our call.
So we
I
have
said I can't help it if she's popular.
this shortened version. What can we do with that?
We
Expand
can
it to tangent.
make it longer.
So we're going to expand it using the identities.
Yes.
So what does our tangent addition identity say?
Tangent X plus tangent Y.
Okay, so tangent of our first angle
Pi
is pi
plus tangent X
plus tangent of our second angle, which is x,
over
over
1 minus
1 minus
tangent pi.
tangent pi
Tangent X.
This is so much fun.
tangent.
Now don't get
X.
confused.
Robert, she said don't get confused, but I have to listen.
Alright, so now we want to simplify this.
Wait.
What?
we not? We just leave it a little nice and pretty.
We could.
You take the tangent of pi, which is negative 1, 0. Tangent is y over x.
Okay, hang on, Jasmine.
Going ahead of the
So, alright, so Jasmine said that we're going to take now the tangent of pi.
Yes,
So, where is pi on my coordinate plane?
that one.
That
Oh
one.
my god.
No,
Oh,
right
yeah.
that one right there.
Yep.
Okay, and what's that point?
Negative 1,
0,
0.
negative 1. Negative 1, 0.
Okay? So, what is the tangent of that spot then?
Well, you know, it's just 0.
Y over X.
Well, what? How do we find tangent using a point?
It's
Y over
Y
X.
over X.
So tangent equals y over x.
So it becomes 0.
So in this case, what is tangent of pi then?
0.
So it's 0. So we have 0 plus tangent of x all over 1 minus, we just said that that was 0,
So that,
times tangent x.
can you just say that it's 0?
So when we simplify it, you end up with tangent x over 1 minus 0, or just over 1. So you end up with just tangent x.
I felt like that was going to be so much more work.
And then we have number 8. It's cosine of pi over 2
Minus
minus x.
I was gonna say, I just need you.
So my group in the back, how do I expand that?
You do the cosine sine.
Shush. What are you talking about? What are you saying?
So it's cosine of pi over 2.
No, no, it's not. Cosine pi over 2, cosine x
Okay?
plus
Uh-huh.
sine pi over 2 sine x.
Good job, Bimby.
Hey, Jude.
What?
Jude.
Alright, so now we want to simplify that further.
Now the cosine of pi over 2.
So we're going to find the cosine of pi over 2. Where's pi over 2?
The bottom, how do you know
The top line. What's that point?
0, 1.
0, 1.
How do you know
So-
what sign?
Huh?
How do you know what sign?
Where? What? Here?
Yeah.
So that's using the identity
Oh,
for
okay.
cosine subtraction.
Okay.
That's just how we expanded it out. So if we want to find the cosine of pi over 2, what's the cosine of pi over 2?
0. Well, oh, it's x over r.
So wait, so our cosine corresponds, cosine equals x over r, and then what did sine equal?
Y over r.
Y over r. So then our cosine of pi over 2 is,
So it becomes sine over.
what's our x value at that point?
0
0, so we have 0 times cosine of x
plus 1.
plus our sine of pi over 2 is 1 times sine of x. So then when we simplify, we have 0 times cosine x, which is just going to be 0, plus 1 times sine x, so we just end up with sine x.
Sine x is the answer.
Yes. Because you're just simplifying this.
Start saying simplify.
Yes. Alright, so now we're going to move on to number 9.
Wait a minute. We can get it Spanish. Spanish.
Alright, so number 9 says cosine of 5 pi.
You guys are not even paying attention.
I am.
Yeah, we are.
I answered questions in
I'm paying attention more. Okay.
Alright, so we're taking cosine of 5 pi over 12. So what do we have to do with this problem?
I'll break it up.
So we have to break it up. So how can we rewrite cosine of 5 pi over 12?
Cosine of pi over 6 plus pi.
What? Yeah.
Okay, so to get that pi over 6 and that pi over 4 though,
You have to do 4 pi over
This is fiction.
Yes.
3 pi over 12.
I mean 3 pi over 12 plus 2 pi.
okay. So the goal of this is you want to rewrite this 5 pi over 12 in terms of angles that we know how to find the exact values for. So what angles can we find the exact values for?
45.
So 45, what's that in radians? So pi over 4. What else can we find the exact value for?
Pi over 6.
What? Okay, so pi over 6, which is our 30.
Pi over 12.
Pi over 3, what's that, our 60? Oops. I was saying 60 and wrote a 6. Alright,
Pi over 2.
we also know pi over 2.
And then just pi.
And there are others. These are our 45, our 30, our 60, our 90. Those are what you're going to use most often, but there are others. So how can we rewrite these so that we can tell if they add or subtract to equal 5 pi over 12? So we want to put them all over 12. So what is pi over 4 if we're putting it over 12?
3 pi over 12.
3 pi over 12,
2 pi over 12.
2 pi over 12,
4 pi over 12.
4 pi over
6
12,
pi over 12.
and 6 pi over 12. So now, out of those 4 angles, are there 2 that we could add or subtract to equal 5 pi over 12?
The first two.
The first 2, okay, so we'll take cosine of 3 pi over 12 plus 2 pi over 12. So then that's essentially taking the cosine of a pi over 4 plus a pi over 6 angle. So now what do we do with this information?
Put it into the identity.
So put it into the identity. So I'm going to erase these just so I have room to expand it. So when we expand this, we have cosine of pi over 4 times cosine pi over 6. This is the cosine addition, so this becomes a subtraction.
Why are you talking so loud?
Sine of pi over 4, sine of pi over 6. So now for this, we actually want to find the exact value for that cosine of 5 pi over 12. So we need to solve this. So that goes back to,
Chill.
our triangles. So how do I label my 45, 90 triangle?
1, 1,
1, 1, root 2. And then my 30, 60, 90, what's across from my 30? Across from my 60?
Root 3.
Root 3. And then my hypotenuse is a 2. So that's what we're going to use to find the exact values for these.
Oh God.
So cosine of pi over 4 is what?
Root 2 over 2.
Is root 2 over 2.
I need to learn to.
Then we're multiplying by the cosine of pi over 6, which is
Root 3 over 1. No? No.
It's 3 over 2.
so it's root 3 over 2.
Oh, it's I thought it might be.
You're welcome.
Maybe.
And then we're subtracting the sine of a pi over 4
It's root 2 over 2.
is root 2 over 2. And multiplying by sine of pi over 6 is 1/2. So then we're just going to multiply these fractions across. So here you're going to get root 6 over 4 minus root 2 over 4. And then we have the same denominator, so we can just combine those. So you're going to get root 6 minus root 2 over the 4. So that's our exact answer for the cosine of 5 pi over 12. Alright, then we have number 10. We're taking the tangent of a 75-degree angle.
If we don't finish this all, is it gonna be on
Yeah.
YouTube?
So we're taking tangent of 75 degrees. Now this one you can leave in terms of degrees. You don't have to switch it over to radians. If you want to, you can, but you do not have to.
Okay.
So how can we rewrite tangent of a 75-degree angle in terms of an addition or a subtraction?
Oh,
Wait,
45 plus.
So 45 plus 30. So tangent of a 45 degree plus a 30-degree angle. So how do we expand that then using our identity?
Tangent of pi over 4.
No, so we can leave that in you can leave it in degrees the whole time. You don't have to switch it to radians. If you want to, you can, but you don't have to.
Tangent, so the tangent
45
So tangent of the 45
plus tangent 30
plus tangent of the 30
over 1 minus
over 1 minus
tangent 45
tangent 45
times tangent 30.
times tangent 30. So now we can find each of those values for tangent. So tangent of a 45-degree angle
1.
is 1. plus tangent of a 30-degree angle
Root 3 over 3.
is root 3 over 3. And then we're over 1 minus the 1 times root 3 over 3. So then when we simplify this, we're going to have 1 plus root 3 over 3 all over 1 minus root 3 over 3.
That's dumb.
Is it
Look at-
root 3 over 3?
I don't like it.
Is that possible?
Just
Root 3 over 3.
Just negative one.
So are you asking where the root 3 over 3 came
Yeah,
from?
you can't do that.
So normally the tangent would be opposite over adjacent, so that'd be 1 over root 3. And then we rationalized it
Oh, okay.
to get the root 3 over 3.
Well, I have a question.
It is.
Yes, ma'am.
Well, you don't think I'm being like some annoying teenager, just like asking this to be dumb, but I'm serious. Like, when am I ever going to need this?
I was thinking that.
Like, I'm being completely serious.
I've been doing research for Tyler Lotta because he actually asked the same question. So I'm currently looking.
So there's no definite.
Right now. We don't even know that we need it for, what we need it for, but we have to learn it anyway.
You go Tyler Lotta. I just wanna cry.
I'm gonna be a nurse.
All right. So we need yes, Shemaya.
Don't we have to sign them for you?
All right. So finishing this problem,
I don't know.
finishing tangent of 75-degree angle. Can we leave our answer like this?
No.
Why not?
Because you can't.
Because we have to rationalize it.
No, don't pause that. Don't pause it.
Okay. So we're gonna rationalize this.
Stop.
So we're gonna multiply the top and the bottom by the conjugate.
Why are you wearing that on your face?
When we multiply through by the conjugate, we get 1 plus 6 root 3 plus 3 all over 9 minus 3.
We're recording.
Oh, that's hot.
No, just stop it.